Hello everyone, welcome to Mr. Academia YouTube channel. We give you the best out of lessons and we hope that you learn from our lessons. Remember to subscribe, press the red button to like all our lessons so that you get notifications whenever we upload new lessons. So subscribe, watch our lessons, share, and also comment to enjoy the best out of our lessons. So we are going to look at circle properties. You can also follow us on our Facebook page, Next Minds Virtual Learning. You like this page, you can also subscribe to Mr. Academia such that you have the best out of our lessons. We are going to look at circles. If you look at what a circle is basically a set of points in a plane at a given distance, which we call the radius from a given point or the center of the plane. So as you can see, this one here is the center of the plane. Then the distance from the center to the circumference of the circle, because the distance around the circle is what we call the circumference. So the distance from the center up to the circumference of the circle is what we call the radius, and it is represented by letter R. So if we look at some other terms, because a circle has many terms, there is this term here which we call the radius, which I've already talked about. Of course, the radius, I've already talked about it. Then there's what we call congruent circles. Two circles whose radii have the same measure are what we call congruent circles, or the word congruent again can be used to mean equal circles. If the radius of the two circles is the same, like for example, this one here, the radius is 3 centimeters, also the radius is 3 centimeters. So these circles are said to be congruent or said to be equal. So another word for congruent is equal. So the two circles are said to be equal or congruent. If we look at the concentric circles, circles are said to be concentric if they share the same center. Like for example, the center is here. So this first circle here, if I call it C1, and then this second circle here, if I call it C2, they all share the same center, which is here, because they are radii. Their radii all originate from the same center, in that the radius of this stops here, whereas the radius of this goes up to this circumference, so it's circumference. So they share the same center, so they are said to be concentric. Then if we look at what the chord, there is another term which is the chord. So the chord is a segment whose endpoints lie on the circle. So the chord doesn't necessarily need to pass through the center, but the endpoints lie on the circle. Or like for example, you can see the endpoint A and B for this chord along the circle. The endpoints for this chord along the circle, but the chord doesn't necessarily pass through the center of the circle, because the center is here. So this line here, the line AB here, as you can see, and the line AB and also the line DC are what we call chords for this circle. So take note of the chords and always differentiate them from the diameter. So if you look at the diameter, a diameter is a chord, but for it passes through the center. It of course joins 2 points on the circle, like point I and J, but the diameter has to always pass through the center, because if the center is here, then the line that passes through the center and then joins 2 points on the circle is what we call the diameter. So it doesn't matter where the points are, even if a point is here and another one is here, and then the line passes through the center like this. So this one will also be called, the diameter of this circle here that we are dealing with. If we look at what we call a tangent is a line. It's a line in the plane of the circle that intersects the circle in exactly 1 point. So we can also call it the line that is drawn and then touches the circle, or it touches the circumference of the circle at only 1 point. So you can see like this line here, if I call it the line AB, this line AB touches the circle at only this single point. There is nowhere else that touches the circle. So this line AB is what we call the tangent of this circle. It's called the tangent of this circle, and the point of contact, we call it the point of tangency. So in this case, this point here is what we call the point of tangency for this circle, because the tangent touches the circle at that point there. Then if we look at a semicircle is an arc on the circle whose endpoints are the endpoints of the diameter. So the diameter, you can see AB is the diameter because it passes through the center. Then if we consider this half ACB, this half of the circle, it's what we call a semicircle because it divides the circle into two equal parts. A semicircle is the other half, and then this other half also is what we call a semicircle in this case. If we look at a minor arc, an arc of a circle, of course, an arc is smaller than a semicircle. For example, if you look at CB, this one here is what we call an arc. But if it was PCB, this would be a semicircle. So if the arc is small, like for example, the BC is smaller than CP, so PC here would be a minor arc because it is a smaller arc. Then if we are to consider this bigger part here, which is running from here up to this side, this would be the major arc. The major arc basically is larger than the semicircle always. So for example, if you look at ABC running from here up to here, this one is a major arc, and because we look at the arc on the circumference part, it's bigger than the semicircle. Then if you also look at CAB, the one running from here up to here, it's also a major arc because it is bigger than the circumference, and it is also bigger than the semicircle. It's not bigger than circumference, but it's bigger than the semicircle. Then if you look at the central angle, the central angle is an angle whose vertex is the center of the circle and the sides are radii of the circle. For example, if you look at this, AK is the radius of the circle, also KB is the radius of the circle. So the angle AKB, this angle here, is what we call the central angle because it makes, it subtends to the center, and then the sides are the radii of the circle. The sides KB and AK are radii of the circle, which we are dealing with here. As you can see in this diagram here. Then if we look at some of the properties or the angle properties of a circle, we shall start by looking at the central angle property of a circle. So and it states that the measure of the central angle is 2 times the measure of the inscribed angle that intercepts at the same arc. That is, if you have a chord, for example, the chord AB is a chord, this AB here is a chord such that it subtends to angles. One of the angles is subtended to the center, meaning that these two, AP and PB are radii, and then it subtends, the same chord subtends an angle to the circumference of the circle. So the angle subtended to the center is always 2 times the angle subtended to the circumference. So that's why this angle here is 2x. This angle is 2x, and then this angle here is x. So this angle at the center is always 2 times the angle subtended to the circumference of the circle, but from the same chord. Looking at another or at an example here, if this angle is 110 degrees, then this angle has to be half of 110 degrees, which is 55 degrees. So if you're given this, then this will be twice this one. This is x, this will be 2x, according to the circle properties. If you look at angles which are inscribed in the same arc, those angles are supposed to be equal. Angles which are inscribed in the same arc, they are supposed to be, they are equal, what we call congruent. So the word congruent here means that those angles are equal. So for example, if you look at this arc here, if you look at this arc QP, so this arc subtends 2 angles, and the angles it subtends the angle A, because you can see the angle, because if I'm to draw a chord here, it subtends two angles, the angle A and then the angle B, because they all originate from this arc QP. So this angle A and angle B are equal. That's why we have here this angle being equal to this angle here. Then if we look at this one here, if you look at this arc AB here, that runs from here up to here. So if I draw a chord, this is the chord that I will be drawing. So there are two angles subtended. There is this angle which is subtended from the arc AB, and then there is also this angle which is also subtended from the arc AB. So meaning that these two angles are equal. So this angle, that's why we have that this angle is equal to this angle, because they are subtended, or they are inscribed within the same arc. So that property is very important, so take note of it. Every angle inscribed in a semicircle is a right angle. That is our next property. As you can see here, some of how it is shown. So if this is a semicircle, if this is actually this one here is the radius, the diameter, sorry, it's the diameter, and if the center is somewhere here. So all angles that are subtended from the diameter, because they will lie within a semicircle, so all these angles here are right angles. So this angle is 90 degrees. This angle is also 90 degrees because they are subtended in a semicircle and also from the diameter of a circle. So they are all 90 degrees. Then the other property is that is the property for segment angles. So angles in the same segment are equal. So for example, this is a chord here. So these angles all are subtended from the same chord and in the same segment. So that's why this angle here is 30, and also this angle is 30 degrees, because the angles lie in the same segment, as you can see there. Then there is the fourth property which says that the opposite angles of a quadrilateral inscribed in a semicircle are supplementary. So this property is basically based on quadrilaterals which are inscribed within a circle. So for example, if you look at this quadrilateral ABCD, it is inscribed within a circle. So opposite angles, for example, this angle is opposite to this. So that's why if you add this angle and this one, you should be able to get 180 degrees. Then also if you add this angle here plus this angle here, you should be able to get 180 degrees, because these two angles are opposite in a quadrilateral which is inscribed within the circle. Then there is this other property here, which is basically for alternate angles. That is, the angle between a chord and the tangent at the point of contact is equal to the angle in the alternate segment. So according to this property, this angle here, because this is a chord here, so the point of contact of the tangent is here. So this angle here is equal to this angle here, because this angle is in the alternate segment. So these two angles are equal in accordance to that property there, which is our property 5. So to summarize the properties, this is the first property that we looked at, and according to this, the angle subtended to the center from the same chord should be twice the angle subtended to the circumference. So if this is 50 degrees, this angle here is 100 degrees. And then this is a semicircle. All angles subtended in a semicircle from the diameter are equal to 90 degrees. That's why this angle here is 90 degrees. Then angles in the same segment are equal. So that's why we have this angle and this one being equal, because they are subtended in the same segment and from the same chord here. Then cyclic quadrilaterals alternate opposite angles in cyclic quadrilaterals, which are inscribed. They add up to 180 degrees. That's why this angle and this one add up to 180 degrees. And then also this angle here and this one also add up to 180 degrees. Then alternate segment, according to that property, this angle here should be equivalent to this one, when this one here is what we call the tangent to the circle, and this is the point of tangency. So thank you for watching. Remember to subscribe and study with us, and share our lessons, like them, share with them, and make sure you enjoy the best out of our lessons. Uh, Subscribe to our YouTube channel, Mr. Academia, to enjoy the best out.